Hey guys, the purpose of this video is just to get a little summary into your notes and also to work through one example with you on that assignment, okay? So we are still graphing exponential functions. You watched that super long video on how we graph these things in sort of stages or one translation or transformation at a time. So here's the summary of what I was doing there when I was making those graphs. For each function, for each graph, we want to graph what's called the parent function first. And in the equation, the parent is going to be the base to the x power. Okay, that's going to be our parent function, and we graph that guy first using two key points. You saw me plugging in the number 0 to those equations as well as the number 1 because that was an easy, those are easy values for me to plug in. After we graph the parent function, we're going to go ahead and stretch our function or make it taller, if you will, or rise up a lot faster, if you will, and that comes from this a value in front. So whatever number's in front of that base, if it's 2 times or 3 times or even 1/2 times, that's going to affect our graph. So we do that next. This is our stretch. Ooh, spelling. Nice. And then if there's a negative, if this happens to be a negative here, then we would incorporate a flip over the x-axis. But most of the time that's going to be positive, okay? We would flip or reflect over the x-axis if that thing is negative. That would be step 3. Now, step 4, the last thing we do is actually move it left or right, up or down. So right here, this part tells me how I move it left or right. And just like before, if it's a minus, we're going to move to the right. If it's a positive, we're going to move to the left. And this right here tells me how I'm going to move up or down. So those steps come last. Now remember, this exponential function is not like the other functions that we've graphed so far. We don't have a vertex that we're moving or an inflection point or a critical point that we're moving here. We just are moving the whole entire function. It does not have one special spot on it. It has quite a few. So those key points, we're going to make them be our special spots, and then we're going to move those accordingly to what those equations tell us to do. Okay, so let's take a look at one example here that you don't need to write down necessarily, even though there's a pencil. If you want to put another example in your notes, that's fine. But I need you to watch this one very carefully. This has, again, one of those negative signs in it, which is a little bit trickier, okay? The next one we're actually going to do is the one that is in your assignment. So graphing this guy right here, we're graphing f of x, which is just like a y, equals negative of 3 to the x plus 1. Now this is not negative 3 as the base. This is positive 3. The difference between parentheses here or all the way around, that's a huge difference, okay? So the parent function is 3 to the x. Our key points would then be, if I plug in the point 0, what would I get? 3 to the 0 would be 1, so I'd get 0, 1 as a key point. And if I plug in the number 1 and make that the exponent, 3 to the 1 happens to be 3. So my key points are 0, 1, and 1, 3. And remember, my general shape of this graph hugs that x-axis there for a while, and then he goes up, 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 exponential growth style, okay? So this is exponential growth, even though it starts with a negative. And the very first thing I do here is graph my parent function. Now the step 2, or the next thing that I do, is I'm going to take a look and see if I have any stretch factor or if I have to multiply it by anything, these y values, okay? And that is not happening here. If it was like negative 2 times 3 to the x, then sure, I would do that. But right now, I don't have anything else in front of that base, just the minus sign that we're going to deal with here in a bit, but I don't have a stretch, so no stretch. And then I'm going to deal with the reflection or the flip. Because I do have that negative sign, I need to flip these points over the x-axis. So instead of being 0, 1, I'm now going to go to 0, negative 1. And this one's going to reflect to 1, negative 3. So my graph now looks like this. Okay, so this was my parent graph, or step 1. Now this is my reflected graph. Nice. And then step 4 would be to do any movement left, right, up, or down. Now in this equation, we don't have anything here for left or right. It's just our x, not x plus something, x minus something. So no left or right, but I do have a +1, which is telling me I'm going to move up 1 unit. So now these fabulous little points right here move up 1 unit, 1 unit, and now my graph does this. And swoosh, okay? The little boomerang effect. Now, yep, it's overlapping, so you may want to make a note on your graph paper which one is your final answer. I'm going to point to it. Final answer, or you can label it with the equation. Either way, you can highlight it, whatever you want to do it in red, set up a key, however you want to do it, but there's going to be multiple stages that we're graphing, but we need to know when we're done, okay? The asymptote here, guys, remember we've been looking for that trend in the equation. The asymptote is right here. It's at it's at +1, sorry, +1. Notice that the leveling off here is happening just right below this 1 on the y-axis. So my asymptote is at +1. My domain is all real numbers because I have arrows on both ends. They're constantly going back and forth. And my range, now notice if this is my asymptote right here at +1, the entire final graph that I made is underneath that area or that line. So I would say that my y values remain less than 1. Or you can say that I'm talking about y values from -infinity until right up to 1, but not including 1, okay? So parentheses there. So you can do that either way, however you want to, but that is the picture that we're going to be making on each and every graph that you have on your paper. Now this one is an actual example from your assignment. It's number 4. So I want to walk you through what we need to do for each one again and what each of these parts mean. So given that this is number 4, we first need to identify what the parent equation is. I would say my parent equation for this one is y equals, then I look up here and decide who is the base. The base is the thing that has the exponent. In this case, that's only the 2. So 2 to the x power is my parent function. What are some key points then, ladies and gentlemen, that I would be graphing on my parent? I'm just going to put those to the side here. Key points for my parent. Well, I'd plug in the number 0, and I'd get 0 here. 2 to the 0 is 1. Okay, then I'm going to plug in a 1 right here on the parent function. 2 to the 1 is 2. So I have 2 key points. I have 0, 1. And 1, 2. And again, this would be my parent function that I'm graphing right now. So this is the parent. I'm going to label that with a P. That's the parent. Now, I'm not done because I have a 5 in front. So I have a stretch of 5, which means these points get 5 times higher. So these y values, I'm going to multiply by 5. So instead of going to 0, 1, it will now go to 0, 5, and 1, 10. Nice, right? So my stretch makes it go 5 times higher. So 0, 5, yep, and 1, 10, nice. So my graph for my stretch, I'm going to put an S there, would look like that. But my final project or my final task was to graph this whole function with everything happening to it. So right here, I'm at this one with the stretch. Now I will do this part where it talks about -2. So that's telling me I'm going to go down 2 units from the last location I was at. So 0, 5, I'm now going to go down 2 units, 1, 2, to right here. And then this one, I'm going to go down 2 units, 1, 2, to right here. And once again, grabbing my function, I'm going to do one of these. Now, why did I go below that x-axis this time when I drew that in? This is my final one right there. Why did I go below that x-axis? How did I know it was going to do that? Well, remember that this is the asymptote, right? So that means it's going to level off right above -2 on that y-axis here. That is the asymptote. I'm going to just label that right there. So what we're talking about is making sure that our graph levels off in the right location there. Paying attention, those up and downs at the end is going to be that asymptote that I'm looking for. So let's talk about the type and how we fill in the rest of these blanks. We made a good picture. You might want to highlight or write that that's your final answer. This one right here, the one in the middle. The type that we're dealing with, this is an exponential growth. How do I know that? Well, it looks like it starts small and gets bigger as it goes to the right-hand side, but also because this base right here happens to be larger than 1. Okay, that's what makes it growth. Where is the asymptote at? Well, the asymptote is at y equals -2. Okay, that was our down 2 movement, bringing that asymptote down 2 as well. My domain is going to stick with the all reals, or you can do -infinity to +infinity. And my range now becomes my y values are greater than -2 or -2 to +infinity. Okay, so this is what we're talking about for each and every one. Color coding is helpful, guys. It's not a lot of work, but it is a lot of steps. You really do need to think about where you're at and what steps you're going to do next, okay? So use some colors, use some highlighters, get that assignment done, and when you're done, you need to watch that next video so that you're ready for story problems the next time I see you, okay? Nobody's going to let you go yet until you get that video watched, all right? I want to thank you for taking good notes today, and I'll see you in the next class. Bye.